Hey, Personalized Learning Geometry, this is Miss Shane. I'm going to record our first lesson for Chapter 7, 721. Chapter 7 is all about quadrilaterals, so shapes with four sides. And in this first lesson, we're just going to focus on parallelograms and kites. And we're going to do a lot of proofs in this chapter, so try to follow along and write down all the justifications that you can. All right, so let's go ahead and get started. All right, so in this first problem, we're going to look at a parallelogram. So if you read the directions, it started out with just the one triangle on the bottom left that has the angles, those three angles marked. So I went ahead and on my PowerPoint, I rotated that triangle around through that diagonal on the now parallelogram. All right, so when we rotate that around, we know that this angle and this angle right here are gonna match up, correspond. We know that that angle and this angle over here are gonna correspond when we rotate it. And then we know that this angle over here and this angle over here will correspond after we rotate. All right, so after that, we can know that a parallelogram does have opposite sides that are parallel. So the way that we can prove that is that these, let me get my highlighter, these alternate interior angles are congruent. So we know that this side must be parallel to this side. Okay? So we can say since alternate interior angles are congruent, then sides must be parallel. All right, and then we can make the same argument for the other pair of sides. So I know since this angle and this angle are alternate interior, those opposite sides are also parallel to each other. So then we know that we just made a parallelogram. So that's the definition of a parallelogram. Opposite sides are parallel. All right, and so I'm going to go ahead and kind of write that down. That's one of our properties. Parallelogram opposite sides are both parallel. What else can the congruent triangles tell us about the parallelogram? Well, we know that since we do a rotation, all the sides are going to be the same length, so its corresponding sides are congruent. So those opposite sides and these opposite sides that I just marked are congruent to each other. So that's going to be our second property. And another property is that our opposite angles are congruent. So like this angle right here, and then this blue angle up here that I just marked, those would be congruent to each other. And I should be writing down both pairs. All right, and then lastly, we know that these three angles, as you can see, the blue, green, and yellow angles are all in one triangle, and the three angles in a triangle add up to 180. And so the blue, green, and yellow are all on the same side of the parallelogram, so that means that these consecutive angles next to each other always add up to 180. So those are supplementary. So that's another property that we can add. So sometimes we call that consecutive, and sometimes we call it adjacent angles. They both mean next to each other. Opposite means that they're across from each other. All right. And we're going to answer the question, if we cut a diagonal, so from D to B, then will the two triangles always be congruent? They should be. So only knowing that opposite sides are parallel, we should be able to prove that. So just like in the last parallelogram, our alternate interior angles are going to be equal. Oops, that is not alternate, so they have to be alternating. So I should have drawn that over here. So I know that this angle, I'll write it over here, angle ADB is congruent to angle CBD. And we know that this alternate interior angle is congruent to that alternate interior angle. So angle CDB is congruent to angle ABD. Okay, we really want to label it with the 3 letters because we have 2 different angles next to each other, so we need to tell those apart. All right, and then lastly, so we have angle, angle, and now we need at least one side to prove that these 2 triangles are congruent. So hopefully you guessed it, this middle side, DB, is equal to itself on both triangles. So we can write that DB is congruent to itself, DB. All right, and so now we can say our last statement, triangle, actually I might write it over here to the left, triangle ABD is congruent to triangle, and then A corresponds to C, so I'm going to start with C, and then we want to go in the corresponding angles. So B corresponds with D over here, CDB. So remember, it's rotated and it's not reflected. And we know that by angle, side, angle. Congruence. All right, so then now I need to draw my arrows over to the final statement. I know I usually do it from left to right, but I just didn't have enough space here. All right, number 50 is introducing something new. So we did this last chapter in chapter 6, proving 2 triangles congruent. But in a true proof, what we always have to do is list our justifications. So our flowchart always has to have justifications. So what we're going to do is add those underneath our bubbles. All right, so I know that dB is equal to itself because anything is equal to itself. The reason underneath that is actually called the reflexive property. So you might make a note when angles or sides are equal to themselves. Sorry, I didn't write that very neat. All right, and then we know that these two pairs of angles up here were congruent because remember the name we gave that is alternate interior angles. So we know that because these sides are parallel. So when sides parallel sides, then we know that alternate interior angles are congruent. So same thing here. We have parallel sides. That means alternate interior angles are congruent. And I do a lot of shorthand. Like honestly, on these bubbles, I probably wouldn't even put the first part. I'd probably just put alt int angles congruent, or alternate interior angles. All right. All right, so we're gonna move on to a kite. So kites are way different than parallelograms. Kites have no parallel sides, but they do have equal sides. Instead of opposite sides being equal, there and there, we have adjacent or consecutive sides that are equal. So they're next to each other this time. And so here, trace the diagram on a tracing paper. We don't really need to do that. And then consider how the diagonals must be related. Sorry, I skipped over some parts. So we need to draw a second diagonal right here. How might they be related? Well, they look like they kind of cross at a 90-degree angle, so they might be perpendicular. So that might be one property. Let's see, let's make a note of another property. It's that both pair of adjacent sides are congruent. All right, so the diagonals are perpendicular. Something else that we could notice is that cuts it in half, so that this half is equal to that half. So one diagonal, and I'll give you a fancy math word, some new vocab. One diagonal bisects, that means cuts it in half. So one diagonal bisects the other diagonal. All right, and then in a conjecture, I'm not actually going to write one out, but it's just making an if-then statement. So what we could write is that if we have a kite, then diagonals are perpendicular. If we have a kite, then one diagonal bisects the other diagonal. Okay, so we're going to prove that, I think we're just going to prove one part of what we just said. What we're going to try to prove is that AD equals BD, so that these halves are equal to each other. That's what we're going to try to prove from our last statement. All right, so in order to do that, we need to first prove that these two triangles are congruent, because we can't just say that AD equals BD. All right, so then this proof is actually pretty easy because it gives us a lot of information right here. So we already know that side AC equals BC. So I'm going to circle that, and underneath for the reason, I'm going to write given. So whenever anything is given to us, we just write that, given. We're also going to write that angle ACD is equal to angle BCD. And again, that is given to us. And lastly, we can say, hopefully you noticed, this side is equal to itself in both triangles. CD is equal to CD. If you remember, we use reflexive property as our reason. Oh gosh, if I can write. Having some issues with the pen. All right. So now we know that those two triangles are congruent. Hopefully you know it's by side, angle, side. So triangle ACD is congruent to triangle, and angle A corresponds with angle B. So we'll start with B and then go to CD. Bisects. And we want to draw our arrows from our 3 facts to our statement. And we just have one extra bubble now. You'll notice we'll have one extra bubble in all the proofs after this. So our extra bubble is what we were trying to prove, that this side equals this side. So just draw an arrow. We can write AD equals BD. And underneath that, our reason is that triangles are congruent. Therefore, corresponding parts are congruent. Or corresponding sides, in this case, are congruent. There is a way to shorten that. I'll show you next class. Okay, so we proved that we have side, angle, side that's congruent. Triangles are congruent. Therefore, all the sides and all the angles must be congruent on that triangle. So that just proved that that diagonal bisects the other diagonal. So CD right here bisects AB right there.